Hello friends, I am Ms. Supriya Jagtap, Assistant Professor in Modern College of Engineering, Department of Information Technology, presenting topic today, stack and queue data structure. Today we are going to talk about stack application for converting expressions from infix to postfix and from infix to prefix. Then also we are going to learn about how to evaluate postfix and prefix expressions. Before moving to the actual algorithm, let's have a discussion about these notations. Infix notation, in which operator will be in between operands. In postfix notation, operator will be after the operands. And in prefix notation, operator will be before the operands. Now let's take an example. This is a given infix expression, and now we are going to convert this into postfix. So let's discuss algorithm first. So for conversion, we have to scan the given expression from left to right. And while scanning this expression will come across the each and every character. So there are four possibilities we can say. It means scanned character can be alphanumeric, scanned character can be operator, or a parenthesis. So whenever we will come across opening parenthesis, we have to push it into the stack. Whenever we'll come across space, blank space, we have to ignore it. Third possibility, either digit or an alphabet. So we have to add that character into the target string or a postfix expression. And the fourth possibility is operator. So whenever we'll come across any operator, we have to perform this task. So what we are going to do if we come across operator, we'll pop the character from the stack and we will compare its priority or the precedence with the operator which we have scanned earlier. So here X is the operator which is popped from the stack and token is the operator which we have scanned right now. So we'll compare its priority. So if priority of the popped character or a popped operator is greater than or equal to the character which is scanned right now or a operator, then we'll repeat these through two steps. So till the precedence of x is greater than or equal to precedence of token, we'll add x into the target string which is popped here, and then we'll again perform pop operation to check the priority of the next operator in the stack. And till the condition is true, we'll do the same thing, and if the condition get false, we'll come out of the loop and we'll push back that x onto the stack. Then if we come across closing parenthesis, we will pop operators from the stack and we will add them into the target string till we come across opening parenthesis in the stack. And at the end, we will stop this scanning when we reach at end of the expression, and whatever operators are there left in the stack, we will pop all the operators and will add them into the target string. So we are going to handle all these four possibilities while scanning the expression from left to right. So let's solve an example. In our given example, first scan character or a first token is 4, which is a numeric value. So we'll add that 4 into the resultant string. Initially stack will be empty. Then second character we are scanning is a dollar. As this is an operator, we have to push into the stack. As stack is empty, we are not going to pop any character from the stack. We simply push dollar into the stack. Now next character is 2, which is a number again. So we'll add this number in the resultant string or a postfix expression. The next character is star, which is an operator. So for operator, anyhow, we are going to push it into the stack. But before pushing, we have to check the priority of the operator, which is there already there in the stack. So our stack is having dollar. It means power, which is having the higher priority than the star. So we can't push star over the dollar. So we have to pop dollar first, add it into the postfix expression or a result, and then we'll push this star into the stack. Next character we are coming across is 3, which is a number again. So for number, we are adding into the result or a postfix expression. Next is operator minus. Again, as it is an operator, we have to push it into the stack. But before pushing, we'll check the priority of the operator which is already present in the stack. As star is having higher priority, we can't push minus over the star. So we have to pop star first, add it into the result, and then we'll push back minus into the stack. Now our next character or a token is 3, which is again a number. So simply add it into the result. Next is plus. Now for plus operator, we have to push it into the stack. Check the priority of the operator which is already there in the stack. Minus is having equal priority. In this case also, we can't add or we can't push plus over the minus. So we have to pop minus first, add it into the result, and then push plus into the stack. Now our next token is 8, which is a number again. So we have to add it into the result. Then we'll come across division operator. As this is an operator, we have to push it into the stack, but check the priority of the operator which is already there in the stack. Now, the plus having the lesser priority than the division operator. So we can push division operator over the plus. Now our stack will have plus and at the top division operator. Now our next token is 4. As this is a number again, we have to add it into the result. Next token is slash or a division operator. Now, this division operator and the top of the stack division operator having equal priority. In equal priority case also, we can't push this division operator into the stack. Before this, we have to pop division operator, add it into the result, and then we'll push this token into the stack. Now we are coming across opening parenthesis. For opening parenthesis, we have to push it into the stack. Then next token is 1. As it is a number, add it into the result. Then next operator or a token is plus. As this is an operator, we have to push it into the stack. Check top of the stack. It is parenthesis. So we can push plus over the parenthesis. Next token is 1, which is a number again. Add it into the resultant string. Then we are coming across closing bracket. So for closing bracket, we are following certain steps, like we will pop all the operator from the stack till we come at this opening parenthesis. So till this opening parenthesis, only one operator is there, that is plus. So we will pop it and add it into the resultant string. And once we are reached at end of the expression, so whatever operators are remained in the stack, just pop it out and add it into the resultant string. Now whatever result we are getting in the postfix expression is our final answer. Now, for the infix to prefix conversion, this is an given infix expression. First of all, we have to reverse the given expression. Here we have reversed it and apply the same steps with some minor changes into it. The only thing or only change we are going to have is whenever we'll come across closing bracket, as we are reversing the string, we'll come across closing bracket first. So we have to push it into the stack. And whenever we'll come across opening bracket, we have to follow the same steps till we reach at the closing bracket. And one more thing is there, while checking the precedence, if the precedence of operator which is scanned or a token with higher priority, we can insert or we can push it into the stack. In previous case, if the equal priority operator we have scanned, we can't push it into the stack. So it was greater than and equal to. But right now in prefix conversion, we'll follow the greater than condition only. So let's solve this example. After reversing, we'll come across first closing parenthesis. So for closing parenthesis, push it into the stack. Then next token is number, add it into the prefix expression or a resultant string. Then we'll come across plus, it is an operator. There is no higher priority operator present in the stack before this plus. So we can push plus into the stack. Next is 1, which is number, add it into the prefix expression. When we come across opening parenthesis, we have to pop all the operator from the stack till we reach at closing parenthesis. So there is only one operator plus till the closing parenthesis. So we'll pop it out and add it into the prefix expression. Then this division operator. For division operator, check the priority of the operator which is there in the stack. Now as stack is empty, we can simply push division operator into the stack. Next token is 4, which is a number again. So add into the prefix expression. Again, there is a division operator. Now this division operator and the operator which is already there in the stack having equal priority. So in prefix conversion, equal priority operator, we can push over the equal priority operator. So we can push this division operator over this slash. Next number or token is number. So add it into the resultant string plus operator. We can't push this plus over the division operator as division operator is having higher priority than the plus. So we have to pop it out first, add it into resultant string. Second operator is also division operator having higher priority than the plus. So pop it out, add it into the resultant string, and then push this plus operator into the stack. Next token is 3. As it is a number, we have to push or we have to add this number into the prefix expression. Next, we come across minus operator, which is having equal priority with this plus, so we can push minus over the plus. Next token is number, add it into the result. Star, which is having higher priority than the top of the stack operator is minus, so we can push star over the minus. 2, add it into the prefix expression as it is a number. Then come across dollar, which is power operator, which is having higher priority than your star or a multiplication. So we can push dollar over the multiplication. Then final token is 4. As it is a number, add it into the resultant string. Now we have reached at end of the expression. So whatever operators are remained in the stack, just pop it out and add it into the resultant string. Now to get the final answer, we have to reverse this result, and this will be our resultant string, that is our prefix expression. As we have reversed the given infix expression, after converting it into prefix, we have to reverse that result back to get the actual prefix expression. So this is an algorithm. These are the some examples for practice. You can solve it by applying these algorithms. Now let's take an example for postfix expression evaluation, where we are passing postfix expression as an input and then we'll get the final answer after solving it. So again, in postfix expression evaluation, we have to scan the expression from left to right and we have to carry certain steps. So whenever we'll come across number, we have to push it into the stack, and whenever we'll come across operator, we have to perform twice pop operation and apply that operator on the popped operands in this sequence. Means first popped element will be stored in operand 2 variable, second pop element will be stored in operand 1 variable, and we will follow the sequence operand 1, operator, and operand 2. So start with the first character. First token is 4. As it is a number, push it into the stack. Second, 2. As it is number, push it into the stack. Dollar, this is power operator. Whenever we'll come across power or any kind of operator, we will pop first. So in this case, 2 will get pop first and 4 will get pop second. So first pop element we have to store in OP2. Second pop element we will store in OP1. So $4 will perform this operation and will get the result 16. 4 power 2 is 16. So push back that result into the stack. So 16 we will push into the stack. Next token is 3. As it is number, push it into the stack. Then star operator, pop, twice pop operation. 3 will pop first, which will be stored in OP2. 16 will pop second, which will be stored in OP1. So 16 multiply 3 will get 48. Store this result back into the stack. Next is 3. As it is number, push it into the stack. Then minus. Perform minus operation on these two popped values. So we'll get 45. Push this result back into the stack. Then 8. As it is number, again push it into the stack. 4. Number, push it into the stack. Division. Pop twice from the stack. So first 4 will be popped. It is stored in the OP2. Second, 8 will get popped, stored it into OP1. Perform division operation in this sequence. You will get 2 as a result. Push this result back into the stack. Next, operand 1, push it into the stack. 1, push it into the stack. Plus, pop twice, pop operation twice. 1 will get pop first. Second one will get pop in OP1 and perform addition operation on these two numbers, push result back into the stack. Next operator slash, again perform twice pop operation, 2/2, you will get 1 as a result, push this result back into the stack. Then final plus operator, again pop twice, 45 and 1, perform addition operation on these two numbers. So 46 is the final answer, push back this result into the stack. Now once we have reached at end of the expression, So whatever element or a value in the stack will be our final answer. So pop it out and display it as a result. So this is how we are going to convert postfix expression into, sorry, we are evaluating postfix expression to get the final answer. For prefix expression evaluation, we are going to perform same steps again with some minor change, that is, whichever prefix expression we are getting as an input, first of all we have to reverse it and follow the same steps. The only difference is first popped element will be stored in op1 variable and second popped element will be stored in op2 variable and will follow the same sequence. Only these two minor changes we have to follow or we have to consider while evaluating prefix expression. So you can try with these steps and get the final result. Thank you for watching.